system, and the other one is forced induction ataupun boosted aspirated boosted induction system. So normal aspirated means that it is sucking air by the action of the piston moving downward only. So for the boosted system, it is using compressor. So the ones that is supercharged or turbocharged, they are using compressor. And so we have two systems for uh, boosted induction, supercharger and turbocharger. And both are compressors, but supercharger is being driven by the gears or the crankshaft, while for the turbocharger is being driven by the exhaust gas. So we'll talk about that later, but we look at the normal aspirated engine. So if you look in the this picture right here, this is normally used for okay, this is the fuel metering device is the carburetor. If when we are in chapter 7, you will see that the fuel system, the fuel metering system can be categorized into two also. It is the carburetor system and also the fuel injection. So normally for the carburetor system, it is used on small engine and like 4 cylinders. But for injection, we are going to use it for bigger engine like 6, 8 cylinders or radial engine. So we'll talk about that later. But here I want to show you the picture of the air scoop. So this is the air scoop. This is the where you have the outside air to go into your engine. So so this what do you call this? This is an updraft. Updraft means draft is the movement of air. So this air is moving upward. So it is called updraft. So at the air scoop, it is taking the air from outside. As you can see, the scoop is very big so that you can have bigger area to allow more air into the engine. So the carburetor is going to have a venturi. It will be measuring. There is a venturi. Let's tengok chapter 7 ni. So this is your carburetor. It is looking like this. So this carburetor will have a venturi. See, this is like when you learn in physics. You have the piping that has a throat. So the piping that has a throat, you call it venturi. So this is like the Bernoulli principle that you have learned. So what is Bernoulli principle? Bernoulli principle is talking about the airspeed, isn't it?
Airspeed.
Dengan pressure kan?
When the pressure high, the speed slow. When the is it right?
Ni gambar dia.
Yeah.
So as you can see here, when the air is passing through the throat, the velocity will increase and pressure will decrease. Okay, so this is happening when it is at subsonic speed. Subsonic speed means that the gas, okay, let me ask you, gas is incompressible or compressible? What is incompressible means? Incompressible means it is not compressible. Tak boleh dimampatkan. Kalau compressible, can be compressed lah. Boleh dimampatkan. So, when you talk about subsonic speed, we will assume, although gas is compressible actually, but at low speed, at subsonic speed, we will assume that all the gas will be incompressible. So dia macam liquid lah. Liquid is incompressible. Tetapi gas is compressible. But for subsonic speed, we are going to assume that they are also incompressible. Kita ada subsonic, kita ada transient speed, transonic dengan supersonic ataupun sonic. Jadi kalau transonic maksudnya mark dia ialah 0.0 macam itulah. From 0.6 mark sampailah ke atas, sampai 1 mark sampai lebih, itu dah gas tu sudah mula dikompres, tetapi at 0.6 and below mark we are going to assume that the characteristic is incompressible for gas, tapi sebenarnya dia compressible, cuma dia tak dikompres semasa at subsonic speed, at 0.6 and below mark. Okay. Jadi bila we are talking about incompressible liquid or fluid at subsonic speed for gas, it is incompressible. So this is true. This is true when it is incompressible. But when it is already at transonic or supersonic, then it will be the opposite. Kalau dia dah supersonic, what will happen is that the velocity will be lowered and pressure will be very very high. Pasal apa? Pasal gas tu dah start compress. Jadi bila dia keluar daripada throat ni, dia akan meletup. So dia akan increase velocity lagi cepat dan dia pressure ni akan drop very low. Itu supersonic lah. Tetapi when we are talking about Bernoulli Principle, it is talking about incompressible fluid. So ini Bernoulli Principle lah ni. Jadi bila kita tengok gambar ni, velocity increase, pressure drop, what will happen to the temperature? What do you think will happen to the temperature?
Yes, sir.
What do you think will happen to the temperature? Kalau pressure dah drop, velocity increase, what happens to the temperature?
Lower.
Pasal apa? Pasal
Sebab
pasal apa?
sebab dia punya
Dia senang je. You nak sejukkan badan, you pakai kipas kan? Kan?
Yep.
Jadi kalau kipas tu maksudnya you gerakkan angin. Jadi lagi laju kipas, lagi sejuk. Betul?
Betul.
So the temperature is lowered when velocity is increased. Very simple. So the aircraft intake, yalah. The air intake sometimes, okay, dibaca sendiri to take maximum advantage of ram air. Ram air tu apa? Rapid air movement. Jadi intake tu biasanya menghadap ke depan lah, supaya angin yang datang tu pasal kapal terbang pergi ke depan, jadi angin akan dipaksa masuk dalam air scoop tu. Pasal air scoop tu menghadap angin lah. Ram air tu, rapid air movement. The location of the air intake is typically found in the propeller slipstream. Slipstream tu maksudnya angin dari propeller tu lah. Extra velocity the propeller imparts. Tetapi kalau you look in this picture, dia tak semestinya duduk di belah depan. Dia akan duduk di belah tepi. Dia punya air intake ni. Pasal apa? Tu nanti kita cakap. Tapi untuk small aircraft 150, biasa dia macam ni lah. Dia menghadap depan. Propeller ada kat depannya. Dia paksa ni masuk. So baca sendiri. Air filtering. So if you look in this picture, nampak ni dia ada air filter. So apa air filter? Do you think? Apa guna filter?
Dia nak filter air tu lah.
Takut ada abu, ada mergas tua, gas kan.
Betul.
Jadi adalah filter kat situ. Lepas tu, yang ni pun patut adalah air filter juga. Dia macam air filter kapal terbang, macam kereta punya lah. Ada macam kertas accordion tu. Pasal apa dia lipat-lipat macam tu? Supaya banyak lagi surface for the air to come in. Lagi besar surface, lagi banyak udara boleh masuk. So, filter maintenance. Fiber material known as flock. Ni. Okay, fuel metering system. Ni nanti kita akan belajar in chapter 7. Kita ada dua jenis, satu carburetor, satu fuel injection. Okay, anyone can tell me, mana tahu you ada experience kan, the difference between fuel carburetor and fuel injection.
Yes, sir.
So can you tell me the difference between carburetor and fuel injection?
Carburetor, basically the fuel injection have what we call for the fuel injection have the sensor and the electronic things, and for the carburetor just the fuel direct from the tank.
Tu betul jugalah, tapi kalau kita tengok dekat bawah ni, dekat hanger kita ni, aircraft kita ada yang pakai fuel injection, tapi tak ada pula nampak komputernya. Jadi tak semestinya tapi sebenarnya the difference between fuel injection and carburetor is that the fuel injected in the carburetor is in the fuel metering device itself, in the body of the fuel metering device, which is the carburetor body lah. Tetapi for the fuel injection, it is not sprayed there. It is sprayed directly into the cylinder, ataupun just outside the intake manifold before it enters the cylinder. Jadi fuel injection tu dia lebih accurate lah. Bila you sukat angin dekat fuel metering body tadi, dekat venturi tadi, fuel tu akan terus ditembak ke silinder. Dia tak tembak dekat dalam fuel injection body tu. Macam carburetor lain. Carburetor dia akan spray fuel tu dekat carburetor body. Ni carburetor body. Ni ada venturi dia. Nampak venturi dia ada 2 stage, 3 stage. 2 stage lah kot. 1, 2. Fuel tu akan di-spray right here. At the inside the venturi. Macam ni lah. Ni dia punya schematic diagram. Kalau yang fuel injection, jadi dia akan ada example of a fuel injection. So dia ada 3 section lah. Satu ni, yang lagi satu sini, yang lagi satu kat sini. Jadi fuel injection ni sebenarnya ni dia punya body. Yang ini, the fuel metering unit ni ialah sini. Nampak ni? Ni cuma keras potongan dia. Dia punya keratan rentas dia. Sebenarnya dia duduk kat sini. Jadi dia ni satu unit lah ni. Satu body. Tetapi yang ni separate. Ni dekat silinder. So as you can see, fuel injection, this is the body and it is directly spraying the fuel out to the cylinder. Tu the difference between fuel injection and carburetor. Yang macam ni nampak ni. Ni namanya pressure carburetor. Ni pressure carburetor. Ni satu body dan fuelnya di-spray dalam body ni juga. Dekat venturi ni juga. Ni carburetor juga, tapi nama dia pressure carburetor. Ni nama dia float carburetor. So the fuel metering system, depending on the size of the engine, usually the carburetor is being used for 4 cylinder. And we call it the bigger engine like 6 cylinders or 8 cylinder, they are using the fuel injection. Kalau pressure carburetor pun ada juga yang pakai untuk 6 cylinder. Macam Cessna 310 kita tu dulu dia ada 6 cylinders, so dia pakai pressure carburetor. Yang 4 cylinder biasa dia pakai float carburetor. Yang injection biasanya untuk bigger engine, 6 cylinders and above, for radial engine and everything. Okay, so intake manifold. Intake manifold is typically including ducting from the fuel metering device to the individual cylinder. Itu maksudnya apa? Itu maksudnya inilah dia. Ni contohnya ni. Starting from the fuel metering device, masuk terus ke dalam. Ini semua ni induction lah ni. Ni induction piping lah ni. Macam contoh yang ni pun, ni daripada ni masuk ke dalam. Semua ni yang warna biru ni punya induction pipe. Induction. Inilah yang warna biru ni. Warna biru punya induction system. Yang warna merah ni exhaust. Tapi yang ni pakai turbocharger. Yang ni turbocharger lah juga ni. Yang ni supercharger. Kalau yang tak ada kompresor, yang tak ada dia tak ada lah pula. Tapi dia cuma pipe sajalah. Dia ada pipe daripada air filter ni masuk ke dalam filtering ni. Lepas tu ada pipe terus masuk ke sini. Itu sajalah. Untuk yang normal aspirated. Tapi kalau yang ada kompresor, masalah yang ada berlaku dalam induction system ni ialah icing. Itu most common problem. Tapi in Malaysia, we don't have that kind of problem. Lain kan kalau you terbang tinggi lah, more than 20,000 feet. Di Malaysia jarang kita nak ada. Kalau macam ni, macam 4-cylinder engine ni, biasanya kita akan terbang tak tinggi. Kita terbang dalam 6,000 feet saja. 6,000 feet tu pun dah tinggi. Jadi in Malaysia 6,000 feet is nothing. Tak ada sampai ice. Tak ada ice punya. Melainkan you go higher. Ada piston engine yang pakai turbocharger, supercharger, dia memang terbang tinggi. Maksudnya dia kena pressurize the cabin. Untuk for the occupants. Occupants, dia boleh bernapas, manusia can breathe normally up to 8,000 feet only. Even 8,000 feet tu pun dia dah mula dah kena hypoxia. You know what is hypoxia or not? Ikhwan Muslim. What? There?
Yes, sir.
What is hypoxia?
Oksigen sikit, sir.
Kalau oksigen sikit, what is the symptom? What are the symptoms?
Pening-pening, nak pingsan.
Pandai. So that is hypoxia. So you don't want people, your occupant, your pilot, and your passengers having hypoxia because they are going to be, they are going to vomit, they are going to pass out, and nausea, and then you are going to have drowsiness, sleepiness. So that is very dangerous. You don't want that to happen. So for unpressurized cabin, only flying below 8,000 feet, maybe 6,000 or 5,000. Higher than that, you need to pressurize your cabin or you need to have mask for your oxygen. So for cold countries, not in Malaysia, but northern hemisphere countries, they are much colder and they have winter. So you don't want to form ice. You don't want to form ice over here or inside the carburetor, because the carburetor has the throat, isn't it? So like I said before, when the air is passing through throat, the velocity will increase and the temperature becomes colder, isn't it? And the temperature will drop. So you will get icing forming on that throat. And when that throat is having ice, then the shape is different already. So you are going to measure the incoming air wrongly. And when you measure the air wrongly, you will give the wrong amount of fuel. So when all the mixture, the fuel and mixture is wrong, then the combustion will fail to happen. So this is the carburetor air temperature or CAT gauge. Carburetor air temperature gauge indicator. So as you can see here that you have a yellow arc here from 5 Celsius to -15. So what does it mean? Is the yellow arc signify? Yellow tu maksudnya apa? Yellow. yellow traffic light maksudnya precautionary, maksudnya berhati-hati. Arc, yellow arc tu maksudnya range yang berhati-hati itu ialah from -15 to 5 Celsius. Jadi bila the needle is at this range, you need to be careful. You need to turn on your carburetor heater. Why? Because ice will form in this region. Okay? But why is it at this 5 Celsius? Kenapa? The temperature yellow arc is being call it worn at the 5 Celsius. 5 Celsius belum ada ais lagi, isn't it? Tetapi bila kapal terbang surrounded by the temperature of 5 Celsius, when you have air movement, then the temperature will further drop, isn't it? So the temperature will further drop to 0 Celsius. So when it reaches 0 Celsius, then you have the moisture in the air, water vapor in the air to solidify. It will be, what do you call it, liquefied, and then it will solidify. So solidifying of water vapor means you have icing. So that is why you need to turn on your carburetor heater. Nah, ni from air lah. So tapi bila you tengok ni yellow arc ni, kenapa yellow arc tu sampai -15? Sebenarnya kalau 0 patutnya semua water vapor in the air has become ice. They have turned into solid. So why is it that it goes to -15? Sebenarnya there will be still a little bit of water vapor exists during this in this region. So below than -15 memang totally dry air lah. Tetapi bila dia in this region from -15 until 0 tu, there will still be some water vapor still exist there, and it is going to threaten your venturi. And they are going to form ice in your pipeline, in your induction system. So if it is 5 Celsius, it can drop to 0 very quickly because of the air movement. And during from 0 to -15 also, there still exists water vapor that still is not solidified. So it is still going to give a threat to form ice into your induction. Okay, so let's talk about fuel evaporation ice. Fuel evaporation ice tu maksudnya apa? Bila you have your skin, you spill gasoline on your skin.
Sejuk ke?
Sejuk lah kan. So fuel untuk carburetor dia tembak dalam venturi, betul? Jadi venturi itu angin dah lah laju, lepas tu kena spray lagi. So bertambah-tambah sejuk lah lagi, betul tak betul?
Betul saya.
Jadi temperature can easily drop from 5 Celsius to 0 ataupun minus. So jadi lagi cepat fuel lagi, masa fuel tu tembak at 5 Celsius especially, then you will further drop the temperature and form ice. That is very dangerous. So tu pasal you kena turn on carburetor heater at 5 Celsius and below. Throttle ice. Throttle ice, nampak ni. Ni a typical apa nama ni? Typical carburetor punya diagram lah. Carburetor punya diagram, dia ada throttle valve. Ni throttle valve ni dia macam dia ialah butterfly valve. Kalau you pernah tengok cerita Fast and Furious, pernah tengok Fast and Furious yang kereta Toretto tu dia ada banyak lubang-lubang dekat bonnet. Tu butterfly valve lah tu, itu induction pipe dia lah. Cuma dia ada banyak pipeline dia tu. Yang ni ada satu je. Jadi rupa dia tu butterfly valve tu dia macam ni. Nampak tu? Dia macam cerita tu lah Fast and Furious tu, tapi dia ada banyak kan. Ni ada satu je. Tapi ini bukannya throttle valve, tapi rupa dia sama macam ni. Tetapi throttle valve tu dia duduk kat sini lah. Ni throttle valve. Yang wastegate tu duduk kat sini. Tapi dia dua-dua ialah butterfly valve. They are both butterfly valve. Tapi ini wastegate, ini throttle valve. Jadi kalau dia throttle valve tu in this position, yang warna hitam ni, itu maksudnya dia full throttle. Other than this position, you will call it part throttle. Kalau dia macam ni, part throttle. Kalau dia fully closed pun, dia part throttle juga namanya. Tetapi sebenarnya masa dia close position ni, sebenarnya angin masih boleh lalu lagi. So very little lah. Other than this position, other than this open position which is called the full throttle position, you will call it by apa nama tadi? Part throttle. Part throttle. Jadi ini part throttle, yang ini pun part throttle. Jadi masa dia full position, full throttle ni, angin maksimum lah boleh lalu masuk ke silinder. Tetapi bila dia macam ni, bila dia part throttle ni, apa jadi? The amount of the air to the speed of the air. Part throttle position will cause the opening to become smaller, isn't it? Kalau dia full throttle, nampak dia besar bukaan. Kalau dia part throttle, bukaan dia kecil saja. Jadi what will happen is that the air velocity will increase. Betul tak? So when you have velocity increase, what happens to the temperature, Mazil?
Yes, sir.
What happens to the temperature when you have increase in velocity? Temperature tadi kalau nak sejuk, buka kipas kan? Jadi kalau udara,
yes, sir.
udara laju, sejuk lah. Tu tujuan buka kipas. So when you have this position part throttle, what you have is that the air will increase in velocity due to the Bernoulli Principle kan. Kalau Bernoulli ada throat je, dia akan laju. Kalau sempit saja dia akan laju. Jadi bila angin laju, temperature pun drop. Jadi bila dia drop daripada 5 Celsius, drop lah sampai ke 0 Celsius. Itu berlakulah icing. Ada ice forming dekat sini. Nanti bila ada ice forming kat sini, lagi sempit. Jadi you punya measurement of angin tu salah. Nanti you measure angin patut masuk banyak ni, tapi you calculate sikit je. Jadi fuel you bubuh banyak. Jadi api tak boleh hidup. Pasal apa? Fuel air ratio tu salah. So fuel air ratio tu apa maksudnya? What is fuel air ratio? General rule for aviation gasoline, air fuel ratio is between 8:1 to 16:1. Only in this ratio that it will burn. If it is less than 8:1, katakanlah 7:1. 7 pound of air with 1 pound of fuel, then it will not burn. Kalau dia exceed this also, like 17:1 ataupun 18:1, tu pun incomplete. Dia tak boleh burn. It will not burn. So it must be within this range, 8:1 to 16:1. So the aviation gasoline, dia punya RON dia ialah 100 and above. Kalau macam kita, kereta kau tu RON 92, RON 95, RON 97. Jadi lagi tinggi you punya octane number tu, lagi banyak haba. Jadi masa zaman dulu lah orang Air Force tu, dia pergi ambil gasoline ni, aviation gasoline ni, orang Air Force ni, dia masukkan dalam enjin diorang. Jadi dapatlah minyak free. Tapi enjin cepat panas lah. Pasal apa? Aviation gasoline ni dia cepat, dia banyak tenaga per pound. In 1 pound dia ada berapa ribu. Kalau yang RON 92, 95 tu dia punya BTU sikit saja. Mungkin 18 ke. Jadi bila enjin cepat panas, kenalah overhaul cepat sikit. Jadi you dapat fuel free tapi you kena overhaul enjin. Tak adalah kerap sangat tapi lebih cepatlah dari yang normal. Jadi apa nama tu, untuk aviation gasoline dia punya air ratio ni, dia punya ratio ni in pound in weight. So 8 pound of air tu sebenarnya 78% of nitrogen, 21% oxygen, 1% of other gases. Di 8 pound of air ni maksudnya 21% of oxygen sajalah. 8 pound of air to the 1 pound of fuel F-gas until 16 pounds of air to 1 pound of F-gas. Jadi itu combustible range. Tetapi pasal apa aku type stoichiometric ni tadi? Pasal ni. 15 to 1 is the perfect combustible mixture. Maksudnya apa tu? Perfect combustible mixture tu ialah tiada lebihan oksigen ataupun tiada lebihan fuel. Jadi at this stoichiometric mixture, the perfect combustible mixture, you will obtain the highest temperature produced, the highest pressure produced. Jadi apa nama tu? Jadi dia punya graf tu, dulu masa tak salah aku ada tunjuk graf tu. Tak ada lah. Inilah aku carikan. Patutnya dalam buku teks ni kau cari lah jumpa punya. Dia punya graf. Ni. Tadi. Alah tadi dah ada. Ni dia. So the stoichiometric mixture is here. Dekat puncak ni. Tetapi if you look in this graph, the best power is here. Kenapa best power tak bubur di puncak? Kerananya kita sengaja lebihkan fuel. Nampak tu? Sini fuel air mixture sini dia reach dekat sini. Lean dekat sini. Lean tu maksudnya kurangkan fuel. Reach ni maksudnya lebihkan fuel. Jadi kita best power tu kita lebihkan fuel dekat sini. Kenapa dia tak duduk di puncak? Kan puncak tu lagi power. Nampak tu? Cylinder head temperature ni lagi tinggi, maksudnya power lagi tinggi lah. Nampak ni? Ni brake horsepower. Jadi kenapa best power tu tak di puncak? Ni sebenarnya best power duduk bawah sikit. Dia sama macam ni. Di buku baru ni salah. Buku lama dia akan duduk di bawah. Jadi pasal apa best power duduk di bawah tu dekat reach, lebihkan fuel sikit untuk aid in cooling. Your cylinder needs to be cool. Air cool is not enough, you need to use fuel to cool down. So itu pasal lah exhaust gas akan bau fuel. Pasal apa? Ada certain amount of fuel that is left unburned because it is going to aid in cooling. Tetapi bila you terbang tinggi, udara dah sejuk, jadi buat apa membazir fuel? Jadi you punya best economy ialah you lebihkan oksigen, lebihkan angin. Fuel tu kurangkan. Pasal apa? Kita nak jimat belanja, fuel tu mahal. Jadi buatlah dekat lean. Lean tu maksudnya lebihkan angin lah supaya jimatkan fuel. Pasal apa? Kita dah terbang tinggi. Terbang tinggi udara sejuk. Carburetor heater tu sebenarnya apa? So in this picture, it is showing you the red line ni. It is not exhaust gas. Ni bukan exhaust gas. Ni adalah sama macam apa namanya, air yang warna biru ni. Arrow yang warna biru ni sama macam arrow yang warna merah ni. Yang bezanya cuma yang biru ni masih sejuk. Yang merah ni sudah dipanaskan. Dipanaskan oleh siapa? Oleh exhaust muffler. Nanti kita tengok exhaust muffler. So ni dia gambar exhaust muffler. Nampak tu? Jadi dia ada dua kompartmen. One is the exhaust gas punya section, exhaust gas punya kompartmen. Satu lagi ialah fresh air punya kompartmen. Jadi fresh air kompartmen ni sebenarnya dekat sekeliling exhaust punya kompartmen. So ini exhaust punya area dalam ni, dan the fresh air akan disekelilingi dekat exhaust punya pipe tu. Jadi kalau dibuka jadi macam ni lah, kalau you tutup dia jadi macam ni. Nampak tu? Jadi nanti kalau you come back here in Miat, nanti you tengoklah the real life. Di exhaust muffler tu dia bukannya mencampurkan exhaust gas tu dengan fresh air, bukan. Dia cuma lalu saja, berselisih saja. Pasal apa dia nak selisih tu? Pasal dia nak transfer the heat from the exhaust gas to the fresh air. Jadi fresh air ni pun akan ambil haba. Pasal dia sejuk, dia ambil lah haba exhaust tu. Jadi exhaust yang keluar tu nanti akan lebih sejuk lah. Lebih sejuk sedikit dari yang sebelumnya. Sebelum dia masuk tu panas, dah keluarkan dia sejuk. Pasal apa? Pasal haba dah transfer. The heat has been transferred to the fresh air. Fresh air ni pasal apa nak dipanaskan? Nak bagi dekat carburetor yang ada ais tu tadi. Yang kesejukan tu. Kadang-kadang exhaust muffler ni bukan sahaja untuk enjin, but also for cabin. For occupants comfort. Pasal apa? Orang yang dalam kabin tu pun sejuk juga. Jadi you bagilah panas sikit. Tapi you tak bagi exhaust gas, nanti matilah orang tu. You bagi fresh air yang dipanaskan oleh exhaust. Jadi pasal apa dia nama dia exhaust muffler tu? Pasal bila exhaust udara yang panas tu sebenarnya noisy. The very hot gas are making a bit more noise compared to colder gas. Jadi bila exhaust tu keluar dia dah sejuk sikit, jadi dia kurang noisy lah, kurang sikit. Kalau exhaust tu buat bunyi dia tu dia panas lah tu. Macam welding kalau you pernah buat welding lah, torch tu, kalau dia keluar api yang panas tu dia bunyi kuat sikit lah. Kalau you dia warna apa tu, orange tu dia tak adalah kuat sangat. Okay. So let's go back to page. So ni butterfly valve juga ni. Ni carburetor heater ni akan dalam cockpit dia ada tulis dalam cockpit tu carburetor heater. Jadi you pull push je. Jadi pull push tu dia akan buat butterfly valve ni kejap macam ni. Kejap macam ni. So kalau you turn on the carburetor heater dia akan jadi macam ni. Jadi dia akan tutup ni, jadi yang angin yang sejuk akan dibuang, angin yang tadi dipanaskan dekat exhaust muffler tu akan masuk ke dalam carburetor. Jadi kalau udara dah panas, jangan turn on carburetor heater. Kalau udara panas yang masuk, lepas tu kau turn on lagi carburetor heater, lagi panas. Nanti akan jadi pre-ignition ataupun detonation. Dah belajar kan piston 1, pre-ignition atau apa, detonation tu apa. Jadi carburetor heater tu bila you turn on kan dia bila cuaca sejuk saja, to prevent icing. Kalau dia 5 Celsius dan below kan. Tapi kalau udara dah panas, buat apa turn on carburetor heater? Jadi off kan dia. Nanti kan ada pre-ignition detonation. So dia jadi macam ni. Kalau on dia jadi macam ni. Okey, itu untuk yang ini. Kalau yang macam ni, Ni dia tak ada exhaust muffler. Dia pakai udara di dalam engine compartment tu. Engine dalam yang pakai fuel injection ni, engine ni besar kan. Tapi engine besar ni dia lagi panas. Jadi udara yang menyejukkan apa nama ni, engine tu menjadi lagi panas lah. Jadi tak payah pakai exhaust muffler. You pakai saja udara yang fresh air yang tadi menyejukkan engine kau tu, masukkan ni macam ni. Carburetor heater on, buka bagi angin daripada engine compartment dalam cowling tu, masuk ke dalam you punya fuel metering. Kalau udara dah panas, tak payahlah turn on carburetor heater, nanti ada detonation. So pakailah udara luar. Dan dia punya scoop ni, air scoop ni pun, dia biasanya bukannya belah depan-depan, dia belah tepi sedikit lah. Pasal apa, the aircraft ni dia yang aircraft yang besar-besar ni biasanya dia terbang lagi tinggi sikit. Kadang-kadang dia pakai kompresor, dia pakai turbocharger, dia pakai supercharger, jadi dia pressurize the cabin, dia boleh terbang lagi tinggi. Bila terbang lagi tinggi, you akan lagi sejuk, lagi akan ada cepat icing. You boleh menyebabkan icing. Jadi kalau dia menghadap betul-betul ke depan ni, nanti icing tu akan bertepek dekat filter tu. Nanti filter tu kena block. Tak nak lah macam tu. Jadi dia akan duduk di belah tepi sikit. On the side of the engine compartment, engine cowling. So lah nanti you come to me and I'll show you. It's aircraft. Okay. So itu untuk carburetor heater. Temperature indicating system. Inilah dia. Carburetor temperature ni. This is the cat gauge. Carburetor air temperature gauge. So dia akan bagi warning at 5 Celsius to -15 lah. Ini untuk jenis aircraft ni. Kalau lain aircraft, lain dia punya indicating system dia. So it depends on the aircraft and the function. Okay, so now we move on to super induction. Supercharged induction system. Supercharger tu rupa dia macam ni lah. It is like this. It is at the back of the engine usually. And here you have the propeller is right here, the compressor is here, and whenever the propeller is turning, the compressor will turn. Unlike the turbocharger is different. If you have the engine running, the turbine might not be running because it is run by exhaust gas. So you need to have enough exhaust gas to push the turbine to turn. So at low speed, the turbocharger is not going to turn. You need to have the engine running at higher speed, at higher RPM to get enough exhaust gas to turn the turbocharger. But here, for supercharger, it is being driven by the crankshaft. Whenever the propeller is turning, because the propeller is turned by the crankshaft, the compressor also will turn due to the reduction gear and everything. It will turn along with the propeller. So why? Because you need to give enough oxygen for all. Let's say you have 18 cylinders. So 18 cylinders, you need to have very big air scoop. Like this one, it is just for 4 cylinders. This one is for 6 cylinders. Imagine if you have 18 cylinders. So how big is the air scoop you're going to install? It is not going to be pretty. Your aircraft is going to be having that very big gap. The aircraft tu tenganga saja. Pasal apa? Nak scoop air for 18 cylinders, which is not aerodynamically very pleasing and also not looking very good. So you will have a very big air scoop, but not as big as pemeluk ke apa, satu bilik ke tak ada. Dia besar juga tapi aerodynamically it is better lah. Dia kecil lah juga. Tak adalah kecil sangat. But the one that is making sure you have enough oxygen for all 18 cylinders at the same amount for each one of the cylinders is because of the compressor. The compressor is forcing in air and pushing it into all of the cylinders with the same amount. And so the compressor is also known as this compressor is also known as the air distributor. Pasal apa air distributor? Pasal dia akan compress air dan akan paksa angin masuk for each of the cylinders dengan amount yang sama. So dia act as an air distributor lah. Dia bagi-bagikan sama rata. Also known as air distributor. Sebenarnya dia ni compressor lah ataupun supercharger. Supercharger impeller. Okay, so now supercharger, we have two kinds of supercharger. One is the single speed supercharger. And then we have the single stage two speed supercharger. So if you have a supercharger, then the brake horsepower ni ialah power that is driving the propeller, the one that is turning the propeller. So if it is normally aspirated engine, maksudnya tak ada kompresor, tak ada kompresor, dia sedut angin pakai piston saja. Jadi powernya tu hanya takat sini sajalah, dekat sini, dekat arrow aku ni. Tetapi kalau you pakai supercharger, dia akan brake horsepower you akan meningkatlah. Pasal apa? Pasal kompresor akan bagi extra oksigen. Bagi more oksigen. And then bila you bagi more oksigen, fuel pun kenalah match. Fuel pun kenalah lebih juga. Jadi bila you bakar fuel lebih, maksudnya you produce more heat. More heat means more pressure. More pressure, more power. More power, inilah dia naik. Tetapi as you increase in altitude, okay, nampak ni? Ni graf ni power versus altitude. Jadi SL ni maksudnya sea level lah. But as you increase in altitude, what happens to the density?
Density low so.
Dia akan low in pressure, temperature pun akan low juga. Jadi bila temperature low maksudnya bila pressure low maksudnya content of the oxygen is lower also. So when you have lowered oxygen, of course your fuel will be lower. Bila you burn lower fuel, then you are getting lower power. See, as you increase in altitude, nampaklah dia drop. Kalau you ada supercharger, dia akan step up, tapi bila climbing your altitude, also it is dropping. Faham tu? Itu untuk single speed. Tapi kalau dia double speed, two speed supercharger. Single stage tu maksudnya ada satu je lah. Satu. Tapi ada two speed. Maksudnya dia boleh tukar gear. Dia macam basikal mountain bike tu. Dia boleh tukar gear. Jadi mula-mula macam ni, kan nanti at certain altitude dia boleh tukar gear. Naik. Lepas tu dia akan drop lah. Pasal apa? You punya altitude increases. Jadi kenapa dia tak buat awal-awalnya high speed? So pressure tu akan power tu akan lagi tinggi dekat sea level. Kenapa? Apa sebabnya you buat dual speed? Kenapa dia nak dekat sini juga? Kenapa dia tak boleh lebih? Kenapa tak buat single speed saja tapi awal-awal dah high speed? Kenapa nak ada low blower? Kenapa nak ada high blower? Siapa boleh jawab tu? Kenapa you tak buat high speed tu awal-awal lagi? Kenapa nak buat low speed dulu, lepas tu dah sampai ketinggian macam ni tukar gear? Naikkan. Kenapa tak awal-awal buat macam tu? Kenapa tak buat awal-awal high speed? Pasal kita tak nak induction pipe tu meletup, bocor. If you increase in power, meaning you are getting more pressure. So if there is too much pressure inside the induction, what will happen is it will leak. Dia akan bocor. Jadi pressure terlalu tinggi pun tak boleh juga. Jadi kita kena maintain lah at least power saja. Pasal power ni pressure dalam induction tu banyak. Jadi kalau you awal-awal dah buat tinggi, sekarang kan meletup pipe induction. Induction pipe ni dia bukannya welding, dia cuma cantum-cantum, bubur cover getah apa semua. Jadi kalau pressure terlalu tinggi, dia akan meletupkan joint dia tu. Getah-getah tu semua tercabut nanti. That is why it is step up only at a certain altitude. Itu untuk supercharger. Now we going to turbocharger. Turbocharger system ni dia lain sikit. Macam supercharger tadi, from the get go, enjin gerak saja dia sudah on. Tapi turbocharger ni pula, dia at a higher RPM baru dia punya turbine tu berpusing. Bila turbine berpusing, kompresor pun berpusing. Barulah dia boleh sedut angin. Jadi kalau exhaust tu tak kuat, exhaust tu sedikit, dia tak boleh nak pusing. Dia kena high RPM, barulah dia boleh tendang turbine ni pusing, dan turbine ni pula akan menggerakkan kompresor. Bila kompresor ni bergerak, maka dia menyedut angin. As simple as that. Jadi, if you look in this graph, brake horsepower versus the altitude, you can see that it is maintaining the pressure. Nampak tu? Macam supercharger tadi, dia akan drop. Tapi untuk turbocharger ni, dia akan maintain. Dia akan try maintain sea level until it cannot maintain anymore. Macam mana dia buat tu? Apa nama tadi? Turbocharger ni, if you look in this picture, it is controlled by the wastegate. Wastegate ni yang akan control the speed of the turbine. Macam mana? Kalau dia tutup habis, exhaust semua lalu sini. Jadi turbine akan lebih laju. Kalau dia buka habis sini, maksudnya banyaklah exhaust akan bypass. Dia tak nak lalu turbine. Pasal apa? Turbine ni banyak kerja. Banyak friction, resistance. So, macam korang jugalah, you don't like resistance, friction semua. You want to bypass that. That banyak kerja. So, you nak kerja senang, you bypass saja. So, wastegate yang paling utama untuk menentukan you punya compressor speed lah. Jadi, okay. Turbocharger dengan supercharger ni, biasanya dia akan buat pressure dalam induction tu at sea level. Macam aku cakap tadi, normal aspirated engine, dia tak ada kompresor. Jadi, bila tak ada kompresor, dia akan sedut udara pakai piston dia saja. Sama macam picagari. Picagari tahu syringe. Tahu syringe tu apa? Siapa namanya? Muaz, you there?
Yes, sir.
Muaz.
Yes, sir.
Picagari tahu tak apa dia?
Tahu, sir.
Tahu kan?
Yang suap ubat tu.
Jadi kadang-kadang you nak sedut darah, betul? Betul? Pakai picagari. Jadi bila you cucuk you punya tangan tu, you nak draw blood. When you want to draw blood, you push out the piston of the syringe and you will see that the blood is taking a little bit longer to fill up the cylinder, isn't it? Bila you draw the blood using syringe, the piston is already out, but to fill up the cylinder of the syringe, it is taking time, a little bit time for the blood to go into the cylinder. So why? Because it has to overcome a lot of friction. The needle is too small, and so only certain amount of blood can pass through. Same thing with your piston engine. For the induction system, for the air from outside to go into your cylinder, it needs to overcome a lot of obstruction, a lot of resistance. One, you have to, the air has to pass through the filter, the air filter, and then it has to pass through the piping, all the cornering, and then the venturi inside the carburetor, inside your fuel metering device. So to get from the outside to inside your cylinder, there's too much resistance, so much obstruction. So the amount of air that should be into your cylinder supposed to be 14.7 psi. But now the air that is going into your cylinder is not going to be that amount. It is going to be less. Maybe 10 psi or maybe 8 psi. So that is for normal aspirated. But if you have a supercharger or turbocharger, then you will have the compressor force in a very high pressurized air into your cylinder. So that is why the cylinder for compressed air, supercharged or turbocharged engine, the pressure can be maintained at sea level pressure. So if outside pressure is 14.7, then the inside also is 14.7 psi, or maybe more. So it depends on the manufacturer. Okay, so go back to turbocharger. So as you can see here, it is maintaining the same amount of brake horsepower, meaning the induction pressure is at sea level pressure lah. So it can maintain this kind of pressure, this kind of power. So it is maintaining the same amount of pressure in the cylinder, in the induction system, until it reaches this critical altitude. This critical altitude means that although you have closed completely this wastegate, the exhaust gas 100%, almost 100% is driving the turbine, but still, when you increase an altitude, you are going to get less oxygen, less air coming into the engine because the compressor has already reached its maximum capacity. Dia dah tutup habis pun, exhaust akan 100% drive this turbine, but still the compressor is sucking, is getting less and less air going into your cylinder. Why? Because you punya altitude terlalu nipis, udaranya terlalu nipis sehingga kan kompresor dah tak boleh sedut lagi. Kalau sedut pun sedut sikit sajalah. Jadi dia punya power pun drop. Why? Because oxygen dah sikit, makin lama makin sikit. So this is what you call the critical altitude. Critical altitude tu altitude di mana you dah tutup wastegate to maximum, tetapi tetaplah tak boleh maintain the pressure. Why? Because udaranya dah terlalu nipis. Dah terlalu nipis, so dia akan keep on dropping lah as you increase in altitude. So to be efficient, you need to not go beyond this altitude. So piston engine biasanya dia takkan go beyond this altitude. Dia hanya maintain dekat bawah ni. Bawah. Okay, boleh. So this is the turbocharger punya apa basically the picture of charger ni. Kalau you come back to Miat besok, kita akan tengok the real thing lah, the actual thing. Dia patutnya ada casing kat sini, ada macam tin foil untuk cover heat semua tu, tapi tak apalah, nanti balik sini dia datang. So dia punya unit tu kecil saja. Ni je bendanya. Ni kompresor dia, ni turbine dia. Kalau buka dia jadi macam ni. Ni turbine ni duduk dalam ni, yang kompresor ni duduk dalam ni. Dia turbine ni akan menggerakkan kompresor ni. So lebih kurang macam ni lah. This is the schematic diagram of the turbocharger. And this wastegate is the one to control the speed of the turbine. And this is the throttle valve, the one that allows how much air should be going into the cylinder. Ada juga yang macam ni, dia tak nak pakai wastegate. Jadi dia fix, dia fix. Jadi dia ni dia takkan ubah-ubah dia takkan ubah-ubah the amount of exhaust gas going over here, exhaust gas going over here. Dia dah di set on ground by the mechanic. Jadi biasanya yang turbocharger ni yang paling simple lah, dia terbang rendah ajalah. Tapi if you want to go higher, you need to have this controllable wastegate. Kalau lagi canggih, ini macam. Lagi canggih, lagi ini macam. So I don't have the time. It's already 12:40. We will continue next week. So remind me, can we stop right here or not? Ahmad Syakir?
Boleh sir, boleh.
So we stop right here lah. And we continue next week. So remind me that we stop at manual control system, page 5-9, ataupun 232, slide 232. Okay, so I think that's it. So if there is no question, I think that's it lah.